So I'm going to write some simple iteration code here, but before I do, I have a quick question for you. And this is not a trick question, it's not a riddle, but I am interested in the first answer, your gut answer that comes to mind. Here's the question. You need to build a straight fence, and it must be 50 meters wide. And you need fence posts every 10 meters. How many fence posts do you need? Do you have your answer? Good. Let's get into the code. So in my JavaScript here, I'm going to create a simple while loop where I'll show you how to do it, and I'll show you one of the most common gotchas with iteration. I want to make a variable called amount. It starts off at 0, and I want to add the number 100 to it 10 times. So I'm going to create a loop to do that. So when I create a loop, as I mentioned, there's always 3 parts to it. So I'll add a few comments here just before we start to build it out. First, we're going to create the index. Then we're going to have the loop that checks the condition. And at some point, we need to have the ability to increment or add to the index. So these are just comments. Let's create an index here. It's very common to call your index I, but you can call it whatever you want. So we'll start off with an index of I equal to 1. Now I'm going to come and do my while loop. Again, takes the same format as ifs. We've got the word while, then our opening and closing parentheses, and then our opening and closing curly braces that represent the body of the loop. So in while, we've got the condition that we're going to check. Just like an if statement, this needs to be either true or false. And what I'm going to say is while I is less than 10, we're going to jump into the loop. And what I'm going to do is add 100 to amount, which I could say amount equals amount plus 100. I could have also used the plus equals format here. And then what I need to do inside the body of the loop is here's where I need to increment the index. I can't wait till I leave the loop, because if I do, we'll never hit that line. The increment must be inside the loop itself. I'm just going to say I++. So every time around, we're going to add 1 to the variable I. We'll then hit the end of the loop, the closing curly brace, and we'll jump back up to the while statement and check the condition again. Now finally, what I'm going to do is use our good old alert box and say the value is, and we'll write out the final value. We're only going to hit this line after we're done with the loop. And we write out the value of the variable called amount. So I'm going to save that and test it. So we're going through this. We're going to add 100 to amount 10 times, which should give us 1,000. But no, we get 900. This is a very common mistake to make. And some of you, I'm sure, have spotted the problem already. I started off with my index set to 1. And then I started the loop. Is I less than 10? Sure it is, it's 1. We then go through the loop, we add 1 to it, it's now 2. Is I less than 10? Sure it is, it's 2. We add another 100. We keep on going. Now at some point, I will go from 8 to 9. We'll loop around again, and then it will go from 9 to 10. And we'll loop around again. We'll check the condition. When I is 10, this will evaluate as false. So the last time we go around the loop was when I is equal to 9. So we're only actually adding 100 9 times, not 10 times. Now what could have worked here is either saying if I is less than or equal to 10, or we could have started off with our index set to 0, because that would have looped around once before we even incremented it to 1. But of course, the flip side problem here is if I did both and we try and save that and run that page again, we're now going to end up with 1100. So I want one solution or the other, but certainly not both. Now these are what is known as off by 1 errors. And it's really easy to go around either 1 too many times or 1 too few if you don't have it exactly straight in your head. And it's not computers causing this issue. The issue is with us. It's an easy mistake to make, even without computers involved. One example of this is known as the fence post error. This is the question that I asked earlier. You need to build a fence. It needs to be 50 meters wide, with fence posts every 10 meters. How many fence posts do you need? Now, a lot of people's gut reaction is 5. Some say 7. But the answer, of course, is 6. And if it's this easy to make off by 1 errors when we're working with really simple concepts like 50 divided by 10 or 100 times 10, How do you think it is when you're dealing with way more complex data with much more abstract start and end positions? And this is just one example. When we start working with collections of data, making sure that we're going through it exactly is quite easy to get wrong. Like with a fence post error, every programmer I've ever known will admit to making off by one errors. So a little extra thought with your loops can go a long way.